Good morning, good afternoon, good evening, and good night to everyone around the world. My name is Itai Silber. I'm from Variscite Ltd. And together with me, Mr. Drew Mosley, the Technical Solution Architect from Mender. We are glad you joined our Secure Over-the-Air Update webinar. So, I'd like to open the webinar and explain why System on Module, why use a SOM. Simply because our new product become to be really complex. As you can see on this slide, MX8 processor block diagram. And imagine its ecosystem complexity connect to the microprocessor. Now consider that all modern products do require a system and application update from time to time, which will be better and easier over the air. And what is a SOM? For those of you that didn't familiar with the SOM solution, this graphic slide will demonstrate it. You can see that the SOM is located on a carrier board, simple board. All the software is embedded on the system on a module, and an optional you have if you need a thermal solution. The next slide is actually a zoom into our MX8 high runner system on a module. You can see that it contains the processor plus the ecosystem, memories, RAM, storage, connectivity, audio, anything. So what are the benefits of using a SOM? I'd like to emphasize 3 main points. Don't reinvent the wheel. Use it and be first to your market. In other words, focus on your expertise and your idea. Make complex hardware that works, take time, and cost a lot. Therefore, by using our SOM that already successfully used by hundreds of products, you will reduce the cost and the risk and invent the time in your product application and idea. And of course, in our modern world, when update is needed, use an over-the-air secure update option to make your life easier and quick update without the need to service recall or send a technician. How to make your life easier? Simply use our pin-to-pin for future scale up or scale down when needed. You can see here that all our VAR SOM product are pin-to-pin for any scale up, which will make your life easier and make it much faster. Variscite and Mender successful collaboration started with the previous platform, the Dart6UL and the VAR SOM Solo Dual, and available today for our high runner VAR SOM MX8 Mini and the Nano. And now I want to hand off the ball and the microphone to Mr. Drew Mosley from Mender that will explain how to secure update your application and system over the air. Drew, please take the lead.
Very good. Thank you so much for the introduction. My name is Drew Mosley, as was said, and I'm a technical solutions architect on the Mender project. Start briefly here, just talking about why we wanted to partner with the Variscite, and it's quite simple because our users demand it. The description that Itai gave about the SOM modules and their flexibility is one that many system developers can relate to, and thus they're using the Variscite chips and they want to be able to do over-the-air updates with them. Our primary supported platform for Mender is the Yocto project, and Variscite has very good contributions in the Yocto community. They have a very mature BSP in the Meta Variscite layer, and they also have contributions into the Meta Freescale layer, general Yocto contributions, and generally keep up pretty well with the Yocto community. So it all works very well together. We have had some specific users on our Mender Hub, which is our community site, that have specifically recommended it. And additionally, we do have some paid customers that are using the Variscite platforms with the Mender solution as well. So briefly, what is Mender? You can read the slide here, but it's a secure, risk-tolerant, and efficient end-to-end over-the-air update manager for device software. We'll dig in a little bit more to some of the details, but just briefly, when we say end-to-end, what we mean is that we have both the cloud side management server for managing the entire device fleet, as well as the client side software for actually handling the updates on a particular device, and all the tooling to help make them all work together. Just briefly who we are, the company behind Mender is actually a company called Northern Tech. They're the ones that signed my paycheck. So if you hear Northern Tech, don't be confused. It's the same company, but Mender is the project. And you see some logos here of partners and customers that we work with. And we're a globally distributed team. I myself am in Florida. We have a team in Oslo, Norway, and a small office in San Francisco. So let's kind of step back at the 10,000-foot level and talk about generically what is necessary for over-the-air updates. The first step is obviously the ability to update software. That's kind of that's kind of table stakes here. But ultimately, you want to be able to update everything on the system, whether it's kernels and device tree binaries, whether it's firmware blobs, applications, libraries, configuration files. Everything on the system we want to be able to update. You also want to be able to handle a large fleet of connected devices and manage them in such a way that you're able to tightly control what goes on specific groups of devices, or keep everything completely up to date as dictated by your application. You want it to be fail-safe. You don't want devices bricked in the field, even in the case of power going out at very inopportune times. Obviously, depending on the exact use case, these devices may be deployed in areas that it's difficult or expensive to get to. Think Arctic weather stations and that kind of thing. You don't want to have to send a technician on site every time to do an update, and you want to make sure that when you do that update over the air, that the risk of leaving a device unusable is minimized. Atomic updates is something that's very important to consider. You don't want any component of the system to know about an update except for the update system itself, ideally. So that way, if you're in the middle of adding half a dozen or so package updates, you don't want to have it get about 3 packages in and fail, or have an application restart with newer versions of the libraries, but maybe not all the new software. You need some integrity verification, pretty standard industry best practices to avoid corruption, and also to avoid potential man-in-the-middle attacks and security issues. Hardware compatibility checks. This is pretty important to make sure that your operators don't inadvertently deploy, say, an Intel architecture binary onto an ARM device and end up with a brick device. And then the code signing, that's obviously important to address the man-in-the-middle attacks that I mentioned briefly just a second ago. So the general components of updating you see here on this slide. There's a lot of detail in here. I'll kind of breeze through this, but you see the difference between the must-have and the environment-specific things. In my view, a lot of the things that are environment-specific or nice-to-have really should be considered must-have if you're going to be doing a production device. Things like compression, decryption, pre and post install actions, that they're not strictly necessary to be able to install software, but they certainly are nice to have to be able to customize software to your particular use case. And then obviously restarting, rebooting, restart a service, whatever, that's going to be very dependent on the exact specifics of what software is updated. And then the post-install sanity checks, the more thorough you can be with your post-install sanity checks, the better off you can be guaranteeing that you're not going to have, you're going to detect issues with your updates as early as possible after they're deployed. So what is it about the embedded environment that makes this a little bit tricky? You know, in the enterprise software update space, generally speaking, you have operators that can easily get hands on the devices, and you know, doing an update using apt-get or whatever packaging system is built into your target distro is a fairly common mechanism. But when you're talking about things in the embedded space, you know, in a lot of cases, these devices are going to be remote. As I mentioned a few minutes ago, you know, they could be things in the Arctic or in you know, in fish farms, you know, out in the middle of the ocean somewhere. So it may be expensive to physically put hands on these devices. They tend to have a long expected lifetime. Many of these devices, you know, live for 5 to 10 years. If you're in the automotive space, it can be even longer. Compared to, say, the mobile handset space, most of these embedded devices tend to last a lot longer than your typical handset. They may be in unreliable or hostile environments in terms of either power or network. You know, if you're building a consumer device, you basically have no control over when the end user of the device is going to pull the power out of the wall or when the battery is going to be completely drained. So you have to be able to handle those kinds of things. Network, you have to deal with intermittent connectivity. Depending on your use case, your devices may actually be in low bandwidth environments. And especially if you're dealing with things that are, say, you know, network gear for coffee shops, they tend to be in very hostile environments where they have to be secure against both physical and network-based attacks. So you want to be able to handle all these things as much as you can, and to be able to account for them when you're designing your over-the-air structure. So what is it that Mender does that makes it good to help improve the overall security of your system? There's two main components that we consider our prime directive and that go into every decision we make: robustness and security. And when we talk about robustness, we basically mean the ability to guarantee against brick devices. And the way we handle that in most cases is to use a fully redundant root file system with bootloader logic to be able to select the appropriate boot partition at boot time. This allows you to get completely atomic updates because your active root file system is not touched by the update process. There are integrity checks built in to avoid corrupted downloads, as well as the signature verification to avoid explicitly hostile actors from injecting bad updates. And then we have things such as device grouping so that you control the rollout, make sure you're not deploying a brand new update to a very large device fleet. Generally speaking, you'll want to use some kind of controlled rollout mechanism to deploy initially to a small group of devices, start to get some device telemetry back, and make sure that things are good before rolling out to a larger fraction of your fleet. And additionally, with the fully redundant root file system approach, that does allow for minimal downtime. The Mender client in this case runs completely in the background. The update is downloaded and streamed to that inactive partition with minimal impact on the existing application stack. And when it's time to switch to the new installation, it's a simple reboot, which can obviously be the speed of that can be increased by standard fast boot techniques. And when we talk about security, we're not reinventing technologies here. We're using industry best practices. We're using secure TLS communication between the server and the devices. Our device authorization workflow uses standard SSL public-private key certificates, as well as our image signatures. And we have the ability to sign the images independently of the server infrastructure, which gives you an additional check against man-in-the-middle attacks. And so far, I've mainly been talking about system updates. The approach of using dual root file systems or dual partitions allows you to update everything on the system, obviously in this case, except for the bootloader. And we kind of ping pong back and forth between the two partitions. The kernel and device tree typically are located within the root file system itself, so that every component of that root file system can be updated via a standard full root file system image update. Additionally, Mender provides supporting updates of applications or any other kind of custom payload that you may have. And typically, this kind of update will happen in the active root file system. So for instance, you could actually do things like Debian package updates or Docker container updates that apply to the currently active root file system and do not require a reboot. They might require a service restart. And these kinds of updates obviously are going to be more appropriate for more frequently updated components of your system, typically your application stack, as well as things that you need to get out really quick and not have to worry about a full image update, both the time and the bandwidth needed for that. In terms of customizing the Mender workflow to your specific application, we have two main components that can handle that. The first one is the update modules, and this is how we accomplish what I discussed previously in terms of handling custom payload types. So this is essentially a plug-in architecture that allows Mender to handle payload types that it doesn't really know anything about. So in this case, you actually have a plug-in script that knows what to do with a particular type of payload, and you use Mender as the transport, and it will unpack the payload. And once that payload is available, it'll identify what type it is, and it will hand it off to your particular plugin. This is how we can handle things like Debian package updates or Docker container updates. We can also do proxy deployments to peripherally attached devices such as microcontrollers that might be running an RTOS. If you have the ability to update that RTOS image from a Linux system that's connected, say, over I2C or something, and you can easily write a custom update module that can handle that, and then you can use the same over-the-air workflow for your Linux system as well as for your RTOS system. Additionally, we have what we call our state script system or state script infrastructure, and this is our mechanism for allowing you to customize the control of the entire workflow process, the OTA process. So in this case, essentially what it allows you to do is allow, retry, or reject certain state changes within the Mender workflow based on the state of your devices. This is useful for the most common use case here is for devices with an end user interface where when it's time to reboot the device, you want to pop up a user dialog to allow the end user of the device to either accept or reject the reboot. And obviously Mender doesn't know how doesn't know intrinsically how to create UI dialogues for every application stack, so we actually give you a plugin mechanism that allows you to do that. This can also be useful for battery savings. So if you happen to have a device that's running on battery and you want to limit how frequently the device connects to the server because the battery's below a certain set point, you can actually delay synchronization with the Mender server based on that until such time as your device is on consistent power or your battery has been recharged. And there's numerous ways that you can use these state scripts to enhance and control the over-the-air workflow. And Mender is also very easily plugged into existing infrastructure. One of the most common use cases for this is in the CI/CD pipeline. All the functionality that you will see in the Mender web UI is also available over a RESTful API, so that your CI system can easily upload new artifacts, issue deployments to your test devices, things like that. So it is very easy to plug in to your infrastructure. And also for developers, Mender can be used as an easy, quick way to get a nice turnaround time in deploying updates for testing onto physical hardware during your development cycle, rather than having to remove SD cards and move them back and forth from one machine to another, or connecting up USB cables to do USB gadget mode updates and that kind of thing. If your devices are always on and connected to the internet during your development cycle, you can actually use Mender as a means to deploy your updates and test. You can do this both at the system level or using the application update modules that we discussed earlier. And finally, for product owners, product managers, that kind of thing, the ability to do OTA updates is something that should be considered at all portions of the life cycle. Ideally, you start thinking about the OTA update workflow very early in your development system, and the development of your system, excuse me. But throughout the entire life cycle, there are needs to do updates. Early on, you'll probably be doing more frequent updates to get new features out, to get bug fixes out. And then as the system is introduced and moves through the growth and maturity phases, it's very, very likely that the frequency of updates will change, as well as the content of those updates will change. Early on, you'll probably be issuing new features and bug fixes to your application. But through the maturity cycle, you'll probably be just moving down into less frequent updates, but for things like CVEs and security issues. So it's certainly important to consider OTA as throughout the entire product lifecycle. And with that, I'm going to present a demo of the Mender system.
This is the Mender Enterprise dashboard. This is where you get a view of your device fleet at a glance, including summary information. I want to start by looking at a new feature that was just released as part of Mender Enterprise, and that's our role-based access control. When you create new users from within your tenant account, you can apply a specific role to each user. Choices are admin, read-only, or CI. Admin has full access, read-only of course is read-only, and CI can only do things appropriate for a CI environment, such as uploading new artifacts from the daily builds. Another feature of our role-based access control system is the ability to add custom roles. With this feature, you can map specific users to specific groups of devices to properly segment your network based on the needs of your OTA workflow. Back in the Devices tab, we see another new feature recently added to Mender Enterprise. We can filter the device list by various combinations of inventory and attribute fields, and even save these searches as dynamic groups. For this demo, I did not pre-authorize the Variscite board to connect to my Mender Enterprise account. In this case, I actually have to go into the pending devices list and manually accept the device into the fleet for security reasons. Once the device has been accepted, the inventory will be transmitted, and we'll be able to see the values of all the inventory fields in the web user interface. Let's take note that the Variscite board is currently running Warrior Target Image 1.0. We see the other values that have been transmitted from the client to the server. Back in the Releases tab, we see that we have two releases that can be installed. For now, we'll select Release version 2.0 and click Create Deployment with this release. In the dialog box for Create a Deployment, we select the group that the deployment should target. Next, we can select various other scheduling items related to the deployment. Finally, we see a summary, and then we can simply click Create. All deployments are created in the pending state. Once a single device has connected to the server and been notified of the pending deployment, then the status of this deployment will change to active. Now we see our Variscite i.MX8 mini system running an obviously unlocked and insecure piece of software. Our over-the-air deployment contains the fix for this, and after it has been installed, the system will reboot and it will come back up, and we can see that the security vulnerability has been addressed. And finally, back over in the Devices tab, we see that the software release that is now listed for this device has been updated as expected.
So, so with that, we'll kind of wrap up here. Just quickly, I wanted to mention, how you can get started with Mender. We do have a 12-month trial period on our Mender Enterprise offering. This includes some proprietary non-open source features, things such as binary delta updates and some advanced filtering and searching and grouping and that kind of thing. The trial period includes a maximum of 10 devices and no credit card is required to sign up. So please just head over to hosted.mender.io and you can get started quickly today. And with that, I think we have time for some questions. So looking at the questions tab here, there's quite a few. Let's see. Yeah, so I see a couple questions about the i.MX6 based SOMs. We had support for some older versions of that. At the moment, we're focused on the i.MX8 SOMs, but if you do have a need for something newer than, I believe it's Thud, the Yocto Thud branch that we're based on, reach out to us either on Mender Hub or at contact@mender.io. And we can see what it would take to get that moved to a newer version. Generally speaking, when we do Yocto integrations, we're dependent on the upstream BSP. I don't know off the top of my head which versions are supported in the Meta Variscite layer for the i.MX6. We can certainly look at that, but definitely reach out to us offline for that. There's a question about a recommended solution for a headless device that can use Wi-Fi. I know that both of the i.MX8 based systems that I worked with recently that are on Mender Hub, the i.MX8 M Mini and Nano SOMs, they both have Wi-Fi in them, if I remember correctly. Itar, please feel free to correct me if I'm wrong on that, but I think they both work with it just fine.
Absolutely.
Yeah.
Yeah, all our products have Wi-Fi and Bluetooth. This is an option that you can add on.
Excellent, excellent. Oh, okay, so are there Yocto recipes available? Yes. So all of Mender is available. We do have a Mender layer, completely open source that's out there for integrating Mender into your own builds. And then on our Mender Hub site, we collect integrations. So that's where you would get the actual information about replicating our reference build on the Variscite platforms with Mender. So that should all be available in open source. And if you actually do integration onto a different device, we would love to have you post about it there and make the integration available to other users. Are local updates via USB device supported? Yes, we do have what's called a standalone mode. Obviously, in this case, you may not be running a Mender server, but you can still use the Mender client on your device to get the fully robust update capability with the dual root file system, rollback, atomicity, all of those kinds of things. So we do support that. Essentially, the model is that the Mender client is just invoked directly on the target as an executable, either from a command line or from some scripting that you would write that would do it at the right time. Is there an embedded web server similar to the way SW Update handles it for local updates? No, we don't. We don't actually have any kind of web server. The standalone mode that I mentioned is simply the Mender client being invoked. You would have to generally write some scripting around it so that it's invoked at the appropriate time. That said, the standalone mode can automatically download the images from an HTTP API. They can be local files. So basically any kind of URI, it can use that directly. Does Mender support Cortex A7 plus Cortex M4F SoC? We certainly have some like that. We don't have any direct support with Mender running on the Cortex M core at that point, but it could certainly be, if you were running a Linux on your Cortex A7, it could certainly be, it could certainly do proxy-based updates to that Cortex M4. During software update, is there any chance of data theft? That's kind of a pretty broad question. We would have to dig into specific attack scenarios. But the general mechanism for Mender is that the Mender workflow is always initiated over TLS by the client. There's no open ports on the device, no push mechanisms involved. It's all pull from the devices themselves. So as long as that TLS encryption is sound, the contents that are being transferred obviously would be encrypted as part of the TLS. And then additionally, as was mentioned, to avoid man-in-the-middle type attacks, we support public-private key signing of the images to make sure that the images you're installing are exactly as developed by your development team. Is Mender limited in any way by headless devices? Not at all. Mender does not require any kind of user interface to run, although with the state script implementation that I mentioned, it can be integrated into devices with user interfaces with appropriate plugins at the appropriate states in the Mender workflow. If I wanted more IoT functions such as log extraction, telemetry, etc., how do I get that? The API for Mender is completely available, so it's easy to plug a Mender in with other systems, such as mentioned in this particular question, AWS IoT or Azure. It is indeed that Mender is singularly focused on over-the-air software updates. At the moment, we've talked about potentially adding additional things like, remote SSH access or, more full-featured log extraction and that kind of thing. But today, Mender is strictly focused on the OTA software updates. But with the API, we do have the ability to merge to work with other systems. Subscription costs, it depends on which plan you choose. Obviously, Mender is fully open source, so if you want to host it yourself, there's no cost for that. In our hosted platforms, we have a couple different plans that are our Mender Professional is basically a flat price per month based on the number of devices. And then that is just done with a recurrent bill to a credit card on file. If we move into the Mender Enterprise plan, that we don't generally have we don't have stock pricing for that. That's generally something we would work with you to develop custom pricing based on essentially the overall usage you expect, the number of devices, how frequently you plan to update them, how big the updates are. And that kind of thing. So ultimately, with Mender Enterprise, it will be a flat rate, invoiced, at terms that we come to in our negotiation on that. How do you configure a Wi-Fi connection on a headless machine? And this is going to depend a lot on exactly how you're configuring your target software. If you're using Yocto, there are mechanisms to do that. I've seen things where the system can actually come up and set up a temporary Wi-Fi access point that you can connect to with your laptop. And then it presents a web interface where you can enter the credentials. That's pretty standard for consumer type devices. You see that quite frequently in consumer devices, and I've seen some Yocto builds that do that. And then otherwise, yeah, I mean, obviously you need some mechanism to get those Wi-Fi credentials in there. They can be applied in the Yocto build, but that's obviously not useful for a device that's going to be going out to end users. So you will need to make arrangements for that, and there are lots of ways to do that. If you want to post that on Mender Hub, I'm sure some of our users on Mender Hub would have some ideas of how they've done it. Is the Mender a closed build, or is its source available to developers? Mender is open source. We do have some proprietary add-ons that the source is not available for, but the core of Mender is open source. All of our both the client and server-side components are available in GitHub. The server-side components are distributed through the Docker Hub as Docker containers, and we have a Docker Compose setup that we can use that. When you're bringing up your own on-premise based system. Does the client connect to the root of trust in IMX hardware? Not today, but it is something we are working on and hope to have as a reasonably standard out of the box configuration. I know when I played with these things in the past, they tended to require customization for specific designs, but we definitely want to have better capabilities with that moving forward. So regarding IoT updates and specifically proxy updates to, say, sensor devices, what's the architecture there? Essentially, Mender is a Linux application, so it's running on a Linux gateway somewhere. And then you would have, if you have, say, a sensor that has an updated firmware module that you need to install, if assuming the embedded Linux system has some mechanism of getting that firmware update into the sensor, whether that's a serial port, a USB, I2C, whatever. Essentially, you would just write a plugin update module that Mender calls at install time, and that update module plugin simply would get the binary blob from the Mender system, and then whatever it needed to do to update the sensor device, it would be able to do that. And then obviously in that case, if you needed to handle rollback, you'd have to back up the image so that you could restore the old image and that kind of thing. If your sensor device was smarter and had some kind of update, dual partition update mechanism, that could be implemented in your custom plugin as well. How do you get started? So I believe we have some links here. That's a good question to move forward to these links. So here's some links on getting started. Specifically, the top link there that goes to our docs page, and that will walk you through a workflow on a Raspberry Pi just to kind of get started with Raspbian. And then you can work your way through those documents and get into more complicated things such as doing your own Yocto builds, building your own server, and that kind of thing. All plans do use the same Mender client, so whether you're on open source hosting your own or all the way through the Mender Enterprise, which does have the proprietary add-ons, the client does not change. At that point, only the server is updated. And even the server, the majority of it is the same. It's a set of microservices that are running. And if you are on Mender Enterprise, then your server will have the additional microservices that are necessary to enable the enterprise enterprise features. Do we have plans for a local API? Yes, we do have plans for it. This will be things such as displaying download progress and things like that. At the moment, the local configurability is limited to the granularity discussed at the state script level, but we do have plans for a local API that will allow you to get more detail and be able to do things such as displaying progress bars and that kind of thing. Is it possible to update all embedded systems in a bigger system at once and to roll the update back if it fails in at least one of the systems? We don't have a directly out of the box solution for that. Anytime you're looking at orchestrating updates at a larger level, it can get tricky, especially as far as error failure scenarios and error, the error paths and things like that. So the orchestration definitely needs to be considered. We are looking at ways to handle at least some of these things directly in the Mender workflow. But when you start talking about these more complicated rollback scenarios, it's generally understood that you'll need some kind of orchestration layer, which obviously in that case you will be using the Mender API, but that may not be something that we have as an out-of-the-box solution depending on your specific use cases. Is there any relation to the software update for Yocto OTA? No, that's a separate project. We know the developers of that. We interact with them, but it's a completely separate project. In terms of hosting costs, yes, it's free if you host it yourself. Whether you're a single developer just playing around or a large enterprise, if you want to host it yourself and do all the work yourself, you can certainly do that. If you want the Mender Enterprise functionality, Mender Enterprise is available as both a hosted version and an on-premise version. So if your security needs are such that you cannot, for your application, use a hosted solution, but you still want the service SLA and the additional features that are part of Mender Enterprise, you can do that in an on-premise version. So with that, I think that was all the questions I have time for. There was several that were that I kind of passed over here. But if you do have additional questions, obviously the contact information given previously, or just email us at contact@mender.io. That'll get to all the relevant folks, and we'll make sure that you get your questions answered. And with that, I think I will turn it back over to the Variscite team.
Thank you very much, Drew, for the great presentation. I just want to answer one generic question that I answered in the beginning. We will share this video and the presentation with all of you. It will be on the beginning of next week. This question come up during those questions that you ask. I'd like to thank you very much for joining us. Drew, if you can take the slide to the next one. So thank you very much for joining this webinar. For those of you on the early morning in the US side, and for all of you in the other side of the world, good afternoon, good evening, and good night. Thank you very much, Drew, and goodbye.